All right, let's get right into it. Today, we're going to talk about something fascinating in the world of AI. How do you shrink an AI's brain, make it way faster and more efficient without, accidentally making it dumber in the process? And this isn't just some random idea. We're getting this straight from the source. This whole explainer is based on a brand new technique coming out of NVIDIA research. Yeah, the very people who are building the hardware and the software that's powering pretty much all the AI we use every single day. So, that brings us to the big question, right? The puzzle we're going to piece together today. How can you possibly take a massive, powerful AI, shrink it down to a quarter of its original size, and somehow make sure it's just as smart as it was before? To get that answer, we've got to first understand the huge problem that AI developers are up against right now. You see, the AI models that power things like ChatGPT or those really advanced coding assistants, they are absolutely enormous. Think of them as these giant, super complex brains. And because they're so big, they are incredibly expensive to run, they can be slow to give you an answer, and they just devour energy. It's a huge bottleneck. So the big idea to solve this is to change how the AI actually stores information. It's kind of like this. Right now, the AI uses these really long, super precise numbers to remember stuff, right? Like 3.1415925, and on and on. But what if we could just use a shorter, simpler number, like 3.14? That's pretty much the idea behind using a format called 4-bit floating point, or FP4. You use these less precise, but way smaller numbers, and you can shrink the whole model down a lot. But, how do you actually do that? How do you perform this shrinking process? Well, the most obvious way let's just say it has a pretty big catch. Okay, so the simplest method is called post-training quantization, PTQ for short. Honestly, you can just think of it like a shrinking ray from a sci-fi movie. You take your fully trained genius-level AI, you point this thing at it, and poof, it's suddenly tiny. It's super quick, it's cheap, it seems perfect. But here's the problem. That shrinking ray, it's not very precise. For the really gigantic AIs, it works okay. But for smaller, more specialized models, this process can seriously damage their performance. The AI gets smaller, sure, but it also gets a lot less accurate. It basically loses its smarts, which kind of defeats the whole point, right? So if that simple shrink rate doesn't work, we need a smarter way to help our new tiny AI get its brain power back. And this is where we get to a brilliant analogy that makes it all make sense. The teacher versus the book. Let's set the scene. We've got our original full-size genius AI. Let's call that one the teacher. Then we have our newly shrunken down model. We'll call that one the student. Now, the student's performance has tanked after being shrunk. So how does it get its intelligence back? Well, it has two choices. Method number one is called Quantization-Aware Training, or QAT. This is like telling the student, hey, go back and reread the entire textbook you learned from in the first place. The problem is that's super complicated. The student can get confused, lost in all that data, and it doesn't always learn the right lessons. It's just messy. And that brings us to the new method from NVIDIA. It's called Quantization-Aware Distillation, or QAD. And this is totally different. Instead of going back to the book, the student's only job is to learn directly from the teacher. It just sits there, watches the teacher solve problems, and its one and only goal is to perfectly copy the teacher's answers. And, this is the important part, its entire way of thinking. Now, this is where it gets wild. Scientists have this really cool metric to measure how similarly two AIs are thinking. It's called KL divergence. Just think of it as a mind meld score. 0 means they are thinking exactly the same. So look at this. The old way, QAT, the score is 0.311. That means the student is thinking very differently from the teacher. But the new method, QAD, the score is 0.004. That is so close to 0, it's nearly identical. The student is learning to be a perfect mental copy of the teacher. Okay, so learning to just mimic the teacher's brain seems way better in theory. But does it actually work when things get tough? Does it hold up in the real world? Let's put it to the test. Because we're not just talking about answering simple questions here. The real challenge is for AIs that need to handle seriously complex reasoning. You know, the kind you need to solve high-level math problems or to write clean, working computer code. For any students out there using AI to help with coding, this is where it really matters. And this chart just says it all. Check this out. On a really hard coding test, the original teacher AI gets a score of 54.3%. Now, look at the student who tried to reread the book, the QAT method. Its score crashes all the way down to 45.9%. It got dumber. But the student who learned directly from the teacher, the QAD method, it scores 53.3%. Whoa, that is an almost perfect recovery. It's smaller, it's faster, and it's just as smart.
So what's the big takeaway here? This whole learning from the teacher idea, it works. It works incredibly well. And that changes a lot of things for the future of AI. This new QAD method basically has superpowers. First, it's super stable and reliable, even on the most complicated AIs. Second, it's not a picky eater. The student can learn from the teacher, even if it doesn't have all the original textbooks. And finally, it creates a truly faithful, smaller copy of the original, keeping all of its skills intact. So what that all means is we can now take these unbelievably powerful, specialized AIs and run them way more efficiently on less powerful computers using way less energy, and we don't have to accept the trade-off of dumbing them down.
So I'm just going to leave you with this question to chew on. What would it mean if the most powerful AI assistants, for coding, for research, for anything, didn't need a massive data center to work? What if they could run right here, on your laptop, or maybe even on the phone that's in your hand right now? Because that is the future that techniques like this are starting to unlock. Smarter, smaller AI, absolutely everywhere.